So guys, welcome back again to my channel. So from in this video I'm going to create a vulnerable binary using C programming, and from that binary we'll going to exploit it and we're going to get a shell from it, right? So I'll be going to create a binary in C, and I'll going to make it so in such a way that, like, while entering the input it will going to create a buffer overflow, and from that we're going to get the shell access into our system. So without wasting much time, let's get started. Okay, so first of all I'm going to create a file over here to create the code. I'll just say touch buffer.c. Okay, so I'll going to start write my code. So hash include stdio.h, then I'll just create the main function. If you all don't know C programming, I'll request you all to refer tutorial spots or Geeks for Geeks to learn C programming. It's a very easy language. So first I'm going to create a array of size 10, okay, of type character. So I'll just take it as name, of size 10. Then I'll going to take this bytes, the array of bytes into the input, right? So for that there are many input statement like scanf, gets, okay, and even a string copy, uh, like to copy the inputted bytes from to the another memory location. So over here today I'll be going to use getas function, okay. So if you all don't know getas, so getas is like an input function in C, which is also known as very dangerous and vulnerable because it does not checks the limit of input which is given by the user. It takes as much as inputs and tries to store into the buffer, and from that it will going to cause a buffer overflow into our code. So if I say getas and the name, okay, over here this, so actual it should take only 10 inputs, but if I try to enter more than 10, so it will also going to take the input beyond 10. So I'll just say name, enter, then return 0, okay. Basic basic statement of the code. Okay, so now over here I'll be going to create one more function which will be going to execute a shell code. So I'll just type that first out, int shell. Okay, so as you all can see, I've created a function named as shell, and it will going to execute a system command, and from that I've entered a parameter which is a bin/ss. So it will going to execute that shell. So over here what I'll be going to do is that, so as you can see, the execution of code starts from the main function, right? So in the main function I've added that vulnerable line get as name and then return 0, but I have not called the shell. So through this getters will be going to calling the shell function, and from that we'll going to get a execute the shell. So I'll just save this. So while compiling, you all should note that for creating the vulnerable code, you should type gcc, then the name of the file buffer.c, then the output file will be buffer, and over here you should add some tags, okay. So like, to make this more vulnerable, we should uh, make the addresses which is pi position independable, executable should be static. So address should remain static even if I run this binary again after few times. So there will be hyphen no hyphen pi. So as you all can see, I'm getting some warnings over here, and it is also saying that so getters could be very dangerous, okay. So we will just try to avoid these warnings. And if I do check sec again over here, check sec, then the name of the file. So as you all can see, no pi, so pi is not been enabled, so we can so the address will be going to remain constant throughout the code even if I stop and run it again. So if I just show you for example, so I'll be going to remove this, that tag hyphen no pi, and if I hit enter that again, and if I just try to do check sec of that file, so you all can see the pi is enabled, right? So this so if this is enabled, we cannot reuse that address of that memory functions. So I'll be compiling it with that tag only, no pi, and check sec buffer. So as you can see, there is no pi. So now the main function is that, so now we'll be going to debug, so now we'll be going to debug this code. So before debugging, what we'll be going to do is that we'll just try to run this exploit, not exploit, that binary. So it is waiting for the input to enter. So if I enter a, so it's saying no. So if I enter more than the bytes, right, the developer said, so as we can see, segmentation fault, so the program don't know where to point actually in the memory. So I'll just going to fire out my gdb, which is a debugger buffer, and from here there is a command called as info functions. So info functions will show out all the function present in that binary. So as we can see, main function and the shell function. So in this binary, the only two main function are these. So I'll just say disassemble main to check the actual code of the main. Okay. So as you can see, it is trying to create a stack over there and then put some values in the register, and it's trying to get input in the gets. So what we'll be going to do is that now after the buffer size, we're going to point the address of the shell, okay, over here, this shell. So I'll just try to copy this address of the shell, and then I'll just try to quit this my program. So as in previous video, I've shown you all how we can try to exploit it using Python script. So in this video, I'm going to show you all using that script only, exploit.py. So basic, like from pawn import input star. Okay, then we're going to analyze the binary context dot binary is equal to elf. Okay, and the binary name is buffer, right? So now, okay, now so we need to create the payload first, right? Payload is equal to cyclic. So we currently don't know the current offset of the file. Okay, so we'll try to get that offset of the file first. So offset, then the name of the shell code, which will be going to edit, okay, shell, and then return address. So if I just try to run this gdb again, if I type cyclic of bytes around 50 bytes, okay, so it will going to create a cyclic pattern of 50 bytes, and then run this code program and paste this input, okay, over here. So then copy first 8 bytes from the rsp register, which is also known as stack pointer, 4 4 5 6 7 8. Then say cyclic hyphen l to get the offset from where the from where it will going to override the instruction pointer. Okay, so I have to add some more bytes, I guess. Yeah, so you can see at exactly at 18 bytes it's trying to crash the code. So we know the offset. So come back to our binary. So we know offset is around 18 bytes. Then we need to print out the shellcode address. So shellcode address, I've already copied it, right, over here. Yeah, shell. Then we need to print out the shellcode address over here, and then return address. I have also explained in the previous video that why I've used the return address, because due to some misalignment of stack, we need to first jump on the return address, and from there we need to jump on the shellcode address, which is our new address. So return address, I can just get it out in the main only over here. Yeah, main. So I've got this also. 36 is that right? Yeah. So now we need to add that, like we need to construct that payload, and we need to send that payload into that binary, right? So first we need to send the cyclic of offset, and then we need to pack. So then we need to pack a return address. So after offset, we need to jump on the return address for the misalignment of stack, and from there we need to jump on the shellcode address. Okay, so pack return, and then pack it on shell. Okay, so now we need to create a process. So io is equal to process, then io dot receive line. So we need to receive that line first, and then we need to send a payload. Send line payload. Okay, and then we want to get the shell properly, so that's why we are using io dot interactive. Okay, interactive interactive. Okay, so I hope this will going to work properly without any errors. So python 3 exploit dot oops sorry python 3 exploit dot py. Let's wait. So I think the program got crashed. Okay, so let me do some changes over here. So I think so it is waiting for that line, right? So what we can do is that io dot receive only, and then try to run exploit. This is also not working, right? Okay, so now let's check it now. I think we are getting some error over here for entering the line. So what we can do is that instead of taking the uh, instead of getting the input, we can just try to directly send the payload, because it is not trying to print anything like enter number and all. So just run this payload again. Yeah, so I think so we have got the shell. If I do ls id, yes, so boom, we got the shell over here. So actually the mistake was in the code only. So I'll just try to exit out this shell. So the mistake was over here. So I have added one line over here. It is io dot receive line. Okay, so it was wrong, because our program was not printing any input statements like enter the shell over here. Okay, things like that. So I've removed this, and directly I've tried to send the payload inside that binary and made it interactive, so that if we try to receive a shell, if we enter some command, it should get reflected back, right? So I've used i.interactive. So if I just try to run this again, so we can see we got a shell. So in this way we can create our own binary, and we can try to learn from our own selves. Okay, so there are many other stack protections like canaries, then partial relo, stack protections, annex bit. So in the coming videos I'll be also going to cover up all of these protections. So till then, keep watching, keep enjoying, and please subscribe to my channel. Thanks.